Hello, everyone. Thank you for joining me. Really glad to be here at Kubernetes Community Days, Czech and Slovak, and for surviving so far. So good way to go for you as well. And on this session, I'm going to talk to you about a very hot topic, about platform engineering. And specifically, I'm going to look into what it is behind the hype and whether it's something new altogether, whether it's just a fancy rebrand of DevOps or maybe something in between. So worth sticking around. Just out of curiosity from the folks here, how many, with a show of hands, have platform engineering in their organization? Or think that they have platform engineering? And I don't care if it's called platform engineering or shared services or other names. Okay, leave your hands up. How many of you work with an organization of more than 100 people? Okay. How many of you more than 200? 400? 1,000? Okay. 2,000? 5,000? Okay. Remember that. That would be very, very relevant for us. So let's start talking about platform engineering. But first, let me introduce myself. My name is Dotan Horovits. Actually, some people told me that according to my surname, Horovits, I have origins here. So I guess at some point I have affiliation with Czech Bohemian origins. I work as the principal developer advocate at a company called Logs.io. Logs.io provides a cloud-native observability platform called Open360 that's based on popular open source tools, some of which you already heard about today on the lectures, like Prometheus, OpenSearch, OpenTelemetry, and others, and provides them as a managed service built for scale. I'm also a CNCF Ambassador. CNCF is the Cloud Native Computing Foundation. We're all here at the KCD, so I assume everyone knows CNCF. So if you have any questions about the CNCF, about the Cloud Native ecosystem, feel free to grab me after the talk. Happy to talk about Logs.io or CNCF or observability or many others. I also have a podcast called Open Observability Talks. That discusses open source, DevOps, observability, platform engineering, SRE, and the likes. So if you like podcasts, it's in English. Check it out on your favorite podcast app. And not many know, but I'm also a platformer, as you can see here from the tweet here, from the picture. So this is why I'm here to talk to you about platform engineering. And you can find me everywhere at Horovits, Twitter, Mastodon, LinkedIn, Medium, whatnot. So if you have any questions and you're shy to ask here, feel free to follow up on me also there. And with that, let's talk about, before platform engineering, let's talk about DevOps, and mainly about what are the challenges of DevOps that we come to solve with platforms, and especially DevOps at scale. So as your organization grows, and you have multiple product teams and multiple product lines and multiple business units and line of business and so on, then you start seeing the following symptoms that you can see here. The first thing is the toil. You start realizing that different teams, different product teams, solve the same problem again and again, each one for their own teams, in silo. Not knowing, mostly in many cases, not knowing even that other teams solve the problem, or even if they do know, the other team solved it so tightly coupled with their own product that it's too much of a hassle to take it from them, and they rather just start from scratch. So that's one problem. The other problem is the cognitive load, okay? We all know shift left. Apologies for those who attended the panel that I participated earlier today, because I talked a bit about shift left there, so I'm repeating. But essentially, the shift left that gave more responsibility, more ownership, more independence to the engineers also came with a lot of baggage. And the baggage is the skill set. Suddenly, the product engineer is expected to know about Kubernetes, about Docker, about Terraform, about Jenkins, about a gazillion other things that are more infrastructure related. And that's a lot of cognitive load. And it's also a defocus, because that product engineer needs to ultimately develop the product, the core business logic of that application. So all of that is pretty much a defocus for that engineer. And the last problem is the fragmentation and inconsistency, okay? There are multiple ways within the organization for creating applications. There's no right or recommended way of doing things. Developers can get confused having multiple ways of doing things and finding the right way of doing things, and also very hard to enforce conventions, security, and compliance, because each team reinvents it and does it locally. And this is exactly the background for introducing platforms and platform engineering. Don't reinvent when you can reuse and adapt. That's the premise that led to platform engineering. And remember that. Don't reinvent when you can reuse and adapt. So now that we understand the premise, the grounds on which platform engineering grew, let's look at what platform engineering is. So, and this is my definition. I looked at actually in the canonical definition. I found lots of them and none of them I liked. So I'd rather just bring my definition and most importantly, break it down to the very important elements that I think you should take out of the definition. So the platform engineering is a DevOps approach in which organizations develop a shared platform to improve the developer experience and the developer productivity across the organization by providing self-service capabilities with automated infrastructure operations. Now, I want again to highlight the main things to take out of it. First of all, it's a DevOps approach. It's not a whole different beast. It's not something else. It's a DevOps approach. And I'll touch upon the relationship with DevOps in the coming slides. And the purpose is to, first and foremost, to improve the developer experience and developer productivity. How do we do that? With a self-service set of capabilities provided across the organization as shared services. Okay? Now, definitions are nice, but I'd like to just go over an example to make it very concrete and simple. And I chose the example that I heard actually from the director of platform, I think they called it cloud platform at Citrix, very large organization. He gave me that example as part of an episode I had on my podcast, Open Observability Talks. So you have the QR code here at the bottom if you want to listen an exquisite episode about platform engineering. But the example is very much representative of the dynamic. So they identified that different teams invested significant effort in certificate rotation. Again and again and again, different teams doing the same thing. So then they went, and very importantly, they didn't go about implementing. They first went to the teams, quantified the benefit by understanding how much they invested, in their case, 300 story points, for implementing their in-house solution, their in-team localized solution. And then they estimated that integrating a platform engineering centralized shared service would be 50 story points. Okay? Now, that's one team. The value is clear. Once they got the buy-in, they went ahead and implemented and provided the self-service certificate rotation as a shared service across all the teams. Okay? So that's, in a nutshell, platform engineering and also the dynamics and the flow that you should be taking. Now, we talked about DevOps and platform engineering, and as you've seen from my definition, platform engineering is not a whole new beast. It's actually a DevOps approach, okay? So what is the relation between DevOps and platform engineering? I get that asked many times, so I put a couple of slides to explain that part. So we all know DevOps, and DevOps uses tools to streamline deployment, management, and monitoring using automation and visualization, right? Platform engineering takes these tools, best practices, and processes and productizes them as reusable services and tools for use across the organization, across the different use cases, across the different product teams. Okay? And remember that word, it productizes them. That's the operative word here. Another way that I like explaining that is looking at the DevOps maturity model. So the standard model goes from initial to managed, defined, measured, and optimized. And when you're in the managed and defined, the earlier stages, you'll see that typically each team creates its own DevOps practices to fit the needs. Usually the deliverables at this point would be blueprints such as Terraform templates, Terraform modules, Docker images, configurations, and so on. And then engineers clone that and add their configuration and use that. But as they clone it, they actually detach from the origin and they lose the connection, okay? And obviously, this is siloed. So actually, there was a very good discussion this morning for those who attended Philip's lecture. I'm not sure if Philip is still here, but about package managers. I don't know who attended that session. That session actually was also echoed some of that pain because he talked about, for example, about Customize. Customize with a K. It's a project that used to be about package management and how it used to be popular at the beginning, and then it was pretty much neglected by most platforms today. And the reason, by most products, sorry, as package manager recommendation, because of the pain it took to utilize that into that when you talked about when you had multiple instances across the organization. So you need to clone the GitHub repo, make the configuration and things like that. And we see similar pains also with Helm charts. I don't know how many of you need to manage multiple Helm charts, and it's becoming a pain as well that you need to do that. So this is the pain. He talked about it from the tooling side. I'm talking about from the processes side. It's becoming a pain when you have multiple of those. And also localized in individual teams. So remember that we're talking about localized within individual teams, so little correlation to other teams and other efforts across the organization. So this is in the earlier stages. Now, as your organization matures and scales, you move your DevOps maturity into the measured and optimized phases. Then the organization starts collecting data and understanding the impact of the DevOps practices across the organization, actually measuring and quantifying it. And then this exposes these pockets of inefficiency where you pay the same toil again and again and again across different teams. And then in this case, the need for consolidation with a shared platform becomes very evident. This is the point where platform engineering becomes material to the organization. And this is, by the way, why I asked at the beginning of the lecture the question about what size of organization you're at from those who do have platform engineering, and you saw that it's the larger organizations that have this facilitation, okay? This instance of platform engineering. So I wanted to bring the use case of another large, high-scale organization like that with platform engineering, Spotify in this case. Actually, Spotify launched their own platform, do-it-yourself from the ground up, and actually later they released it, they open-sourced it and donated it to the CNCF under the name Backstage. A fascinating journey. I'll mention Backstage later if time permits. But they shared the numbers about their engineering organization internally, and they showed that their developers are 2.3 times more active in GitHub. They create 2 times code changes in 17% less cycle time. They deploy software 2 times, twice as often, and their software is deployed for 3 times as long, and 5% more likely to be at Spotify 1 year later. And yes, cognitive load also bears cost in terms of losing good engineers and the churn of engineers. So this is definitely something to think about. You have the QR code for another fascinating episode I had with the director of platform at Spotify. She relayed very nicely here about the story, so check it out there. But anyway, I want to talk about shared services. Okay, and shared services, I keep on saying shared services, but it rings a bell, right? Rings a bell from platform as a service, PaaS. I don't know how many of you remember this period where we divided all the migration to cloud and cloud IT into this very neatly set IaaS, PaaS, and SaaS, infrastructure as a service, platform as a service, software as a service. Who remembers that? Okay, we have a few that went through that era. So essentially, the problem back then was very simple. IaaS was okay, it was pretty stable then, especially with AWS. We had the compute instances, we had the networking, we had the storage. And then many tried starting businesses as SaaS model on top of cloud. And then they realized that the gap is very big. I need to create my, I don't know, e-commerce thing or online shop or whatnot. Doing that straight on top of the IaaS was very, very low level. And this was the ground for building the PaaS. Things such as Heroku, AWS Elastic Beanstalk, Google App Engine. And they brought a very elegant solution. You get very nice simplicity. I want one database, I want one caching solution, one this, one that. You plug it, you create the relation, the connection, and that's about it. Okay? But it didn't catch. How many use any of these PaaS services today? Anyone? Okay, we have 1, 2, okay, 2. So the most of us don't use that today. So it didn't work. And then the question is, okay, you bring platform engineering, all this buzz, is that ultimately PaaS all over again? And I've been through that PaaS era. I even worked at a startup called Cloudify that was squarely in this business. It was then sold to Dell EMC and all of that. So I lived that, and I'm here to tell you, no, it's not PaaS all over again. And I want to explain to you why PaaS, in my perspective, didn't work, so that you can see why platform engineering takes a different approach, or at least should take a different approach if you apply it correctly, and I'll tell you what correctly is. So PaaS had a few problems. One, it was too opinionated. As I said, you got one database, one thing, but it doesn't work that way these days. These days, you see the organizations have different runtimes, deployment methods, and so on. We need more flexibility than that. Secondly, there was vendor lock-in. Okay, if I wired all my infrastructure with Heroku, that was what I got. I got Heroku and I'm very much locked in. And a related problem is, what if I have already Terraform and I have Docker images and I have other assets? How do I reuse them or even migrate them? Okay? So these are the problems with PaaS, and what I'm here to tell you is that we don't need platform as a service. We need platform as a product. So how is that different? It different several material aspects. First, it's developed by in-house platform engineers sitting side by side along with your product engineers. So they can actually go there and understand the feedback and create short feedback loops to make sure that it's suited, okay? That was when I was a product manager in past life, that was my dream, to go to the users, get feedback, sit and see with them and see how they use it, get them to answer surveys and so on. It's very, very difficult, trust me, when you do that with external users. Now the users are part of your company. You can actually do that much, much easier and get their collaboration and feedback. and without any problem of exposing internal issues and so on. So that's on one side. Secondly, because it's our own platform engineering team, it's suited for our organizational conventions, tooling preferences, development and deployment styles, compliance constraints, and so on. And thirdly, and very importantly, it's also, or it should be, optional and composable. I also stressed it out for those who attended the panel discussion earlier today. I'll stress it again here. Optional and composable. So every team can take whatever suits it out of the pile. They don't need to buy into your entire suite, entire platform, all or nothing. They can choose, pick and choose what suits them, and from the inventory, from the catalog, whatever it is. Treating your platform as a product starts with treating your engineers as your users. And that's very, very important. So really, it calls for a product mindset, and I see a fellow here that knows the need for that. We chatted about it earlier, and I want to emphasize that. Maybe, again, because I come from product background, but let's be very clear. Everything that you do as a product manager for external products, you need to do here. First, user research. As I said, the fact that there are your engineers in the product team in the same organization does not mean that you know their pains. Go to them, sit with them, understand their requirements, understand their pains and needs, and define their requirements based on that. Secondly, be data-driven, quantify the value, measure the success, and thirdly, balance simplicity with flexibility. We engineers are very problematic beasts. On the one hand, we like simplicity. Don't bother me with all the details and all the under the hood. Just give me something that works. On the other hand, we want all the flexibility. Hey, in Docker I could do minus this and I could do that. Are you abstracting this away from me? No way. So as a product manager, you need to balance the split brain and strike the right level of abstraction. Now, in addition to the needs arising from the various individual product teams, you also need, as platform engineers, to also address cross-organizational requirements. So remember, when each team implemented its own stuff, it was very difficult to enforce security and compliance. Now that we have a central platform, it's become much easier. So this is an example of a very important value of platform engineering. So you can see here compliance with relevant regulations, standards across the organization, establish consistent conventions, standards, and style guides, and also cost efficiency, FinOps approach, consolidating vendors. Think about each team going to a different vendor, less of a power that you have with that vendor, unless someone that can actually meddle with that. Whereas when you have a central platform team consolidating, you come with more volume, you can come with someone who can bargain better deals, reduce the costs, maybe even doing multi-tenancy, sharing resources between teams across the organization, and so on. FinOps-wise cost, something that is very important these days for many organizations. Also reducing overhead by instilling best practices and golden path solutions. So benefits and needs that platform engineering serves centrally beyond the individual product teams. Now I want to look at what the platform capabilities are, and I used the model that is taken from a white paper that came out from the app delivery tag, technical advisory group within the CNCF. A fascinating white paper. You have the QR code there. You can scan and check the full white paper. I wanted to highlight the model that they provide. So you can see, let's start bottom up. Obviously at the bottom you have the infrastructure, the cloud providers and other platforms that you use, and then the platform capabilities surround a lot of a suite of capabilities, environment and resource capabilities like runtime environment, Kubernetes, infrastructure, databases, caching, messaging queues, and so on. There's also, this is the production, there's also the release lifecycle elements like pipeline, build, CI/CD, think about your Jenkins, Argo, Flux, and so on, even chaos engineering in some advanced cases. Could even be the dev environment itself, like managing the repos and the registries, think about your org Docker registry or a Git repo and so on, SBOM management, even dev environment as a service. I gave this example earlier on the panel. And security-related identity, RBAC, AAA, like authentication, authorization, access control, static code analysis, making sure that each team does static code analysis, artifact scanning, policy enforcement, all of that. You can embed it as part of the shared services, secrets management, certificate management. That's on the security. On the observability, I come from the observability space, so that's what I do day in and day out. And all the suite of observability, which includes the code instrumentation, enrichment, local daemons, collectors, sampling, aggregations, roll-upping, indexing, storage, visualization, alert management, all of that, someone needs to take care of, okay? So again, as a shared service, for example, with my company, this could be an element with Logs.io that you provide, and then you get an end-to-end solution on the observability piece, okay? In some places, they go into even higher level, like business-related reusable services like billing, metering, cloud account management, and so on. So it's really up to your organization where the line draws. And what it provides above, you see the platform interfaces across UI, API, and CLI. Including web portals, many talk about internal developer portals, self-service APIs and CLI tools for automatically provision, and golden path templates and docs. So check out the white paper from the Tag App Delivery, and there's another one white paper about the platform maturity model, fascinating work by the CNCF. Now, I mentioned Backstage, so just briefly, Backstage, that project that started as an internal developer platform at Spotify, and then they open sourced it and donated to the CNCF back in 2020 to the sandbox and moved to incubation in 2022. And by now, you can see very impressive numbers. 150 plus plugins, 3,000 plus companies adopting it, 25K plus stars on GitHub, and thousands of forks and more. So really impressive. As I mentioned, there's a very nice episode with the director of engineering there that talks about both the internal development and then the open sourcing of that project and donating into the CNCF and what that made and how that boosted the project. Fascinating journey. So we're about to run out of time, so I want to summarize what we've seen. Several important things. First, remember that. Don't reinvent when you can reuse and adapt. And the reuse and adapt, that's exactly the piece that platform engineering should provide. So platforms improve the developer experience and the developer productivity by removing toil and cognitive load. Platforms promote cross-organizational consistency, security, and cost efficiency beyond the individual developer experience and productivity. And as your organization matures and scales, then you'll see the need. So if you say, I don't see these pains, maybe your organization is not yet there. Don't enforce platform engineering when it's not really needed, when you don't see. It will come naturally as your organization grows and scales out. And lastly, but definitely not least, treat your platform as a product. So again, if you want further reading about this, I have an article I wrote already, I think, 2 years ago about platform engineering. You're welcome to check it out. Provides much more in-depth about the points I touched upon here. And with that, I'd like to thank you very much. I'm Dotan Horovits, and thank you very much for listening.
Thank you, Dotan. So we have at least one question. I'm going to read it. So in the last years, following the DevOps hype, we saw appearing dozens of XOps, such as FinOps, ToolOps, DataOps, GitOps, MLOps. So what's your view on this?
Okay, that's a bit off topic for platform engineering, but in a way it's related because platform engineering does serve some of these. So I think at least on the ones that you mentioned. I don't know all the X's, probably I'll find some new, but I definitely see that FinOps is real. I see that actually very much increasing in the last couple of years, that it's becoming a concern. And actually I see many organizations realize that once they get proposed the maturity model into the measured and optimized phase, they realize the pockets of inefficiency also on the FinOps side, like instances that run idle for a lot of time and not shut down, like underutilized and so on. So I think FinOps is very real, and projects to optimize, to reduce internal cost have been proving like tens of % of improvement in the cost. So that's definitely real. Security, we don't need to talk about it. Whether DevSecOps is something different, a different beast than the traditional security is a whole different lecture, but definitely it's a topic. So I think they're material, and I think it's important to also understand it's not a role. That's something that people tend to get confused. So do I hire now a DevOps guy? Do I hire a FinOps guy? Or is that a discipline that we need to instill within the organization? And this is something that I see oftentimes, that I see, okay, I tick the box because I have a DevOps guy, so I have DevOps. No, you don't have DevOps, and it's same for FinOps and for DevSecOps and so on. You need to, like in platform engineering, you need to instill a culture where you have this in place, each one with its own respective thing. So I see that also shifting left more to developers, so developers take more ownership in the security, DevOps, and so on. That's my take in a nutshell.
Thank you. One more. What do you think are the important first steps building a platform in an organization following the Go decision?
So I think it's very important. If you got the go decision, the green light from the leadership, it's important to understand what was the thing that ticked the box. Like what was the OKR, the objective key result of the organization that you got them bought into that. If it's, for example, preserving engineers, reducing the churn in engineers, whether that's increasing the dev velocity, because that will be also your top OKR for your project. So that's one, to know what you're trying to show afterwards to the leadership, that the project success achieved its goals. Then you need to find the sweet spot to start. Sweet spot is like, we talked about the pockets of inefficiency, find the most obvious and painful pocket of inefficiency. Recurring in many teams, touches a very sensitive point of the organization, something like that. Use that as your beta, your pilot, your proof of concept for that. And then find your champions. You don't need to tackle it across the organization. Find one team that is more early adopter, that is more bought into the idea. Do the pilot with this team, then find the success, show it to the other teams within the same shared service to get this shared service propagating across different teams of organization. Then you have one shared service as a success across the organization. Then you show that. Then you find the next one. This is how I would do it in the first phases.
Thank you. Do we have any other questions? Maybe one more, last question of the day.
Come on, I couldn't have been that clear. Okay, so feel free to reach out to me also in private if you're too shy, or reach out at Horovits in whichever medium you like. And thank you very much for listening.
Thank you.